All right, good afternoon and welcome to Master Talker online class. In this video, we'll be talking about circle geometry. Okay. Now, in circle geometry, if I have this now, for example, if this is a circle, let's talk about a circle. If I have a line that is drawn from one circumference to the other, you know that this line is called the circumference. Okay. If I have the center now, a chord is a line that is drawn from one circumference to the other. Okay. Yes, so this line is called a chord. This is called a chord. Now, from here, this is called, inside this place is called the minor segment. Okay, while outside the bigger one is called the major segment. So a chord divides a circle into minor and major segments. Then the line that is the line from here to here is called, this line now, just from here to here, is called the minor arc. Minor arc. Why the big one now from here round to this point is called the major arc. The major arc. Okay. Now, if I have, let me still draw another circle. I want to explain something for you. Now, there is a special chord. You know that a chord is any line that is drawn from one part of the circumference to the other part of the circumference. Now, if that line is drawn, that is drawn passes through the center, then that line is called a diameter. Okay. Yes. So a diameter is a chord that passes through the center. As simple as that. Okay. So now there's another one you need to know. If you have this as well, if you have this is the center, and you have a line that is drawn from the center to any part of the circumference, and another one that is drawn from the center to any part of the circumference. Now, any line that is drawn from the center to any part of the circumference of a circle is called the radius. Now, if you look at this now, automatically it means that what? A diameter is equal to 2 radius or 2 radii. From the center to this part of the circumference is radius. From the center to this part of the circumference is radius. So 2 radii, the plural is radii. 2 radii is equal to 1 diameter. Okay. Now, another thing you need to know is that now when you have two what is it called? When you have two radii, okay, now the line from here to here is equally called the minor arc as well. The minor arc, while the big one is called the major arc. Okay, the major arc. Then this angle here, there's an angle here. This angle is called what do we call it? Okay, it's an assignment for you, so you need to find out what the angle is called. But I'm still going to tell you about that. So, but for now, let's know this particular one about a circle. So now, if you want to define a circle, how do you define a circle? A circle is defined as the radius of all points equal distance from a fixed point. The radius of the locus of all points, not radius. A circle is defined as the locus of all points. A circle is defined as the locus of all points x, y equal distance or equidistance from a fixed point. Now, what do I mean by that? If you have any shape that is round like this, okay, that shape is only a circle. If we have a fixed point, that fixed point is called the center of the circle. The center. Okay, if you have a fixed point now, center, now, and anywhere you stand on this circumference now to this center of a circle is equal, then you call it a circle. Like if I stand here to this place, should be equal to from here to this place, from here to this place, from here to the anywhere you stand on the circumference to that fixed point, which is the center. If they are equal, then that shape is a circle. So a circle is defined as the locus of all points equal distance from a fixed point. Okay, now let's move. The next thing you need to know are just the properties of a chord. If I have a chord like this, this is a chord, and if this is the center, any line that is drawn from the center of the circle to this chord, okay, met this chord at angle 90 degrees, okay, and then it divides the chord into two equal parts. Okay, yes, a line that is drawn from the center to the chord, divide it into what? Two equal parts, or bisect it. Bisect means dividing something into two equal parts. Okay, very important. So if you have a circle like this and you have any chord anywhere, once you have the center of the circle, any line that is drawn from the center of the circle to that chord met this chord at angle 90 and it bisects the chord. Okay, the line must be equal. Okay, so that's another thing you need to know about properties of a chord. So now let's move into the main thing, which is circle theorem. Now we have some theorems that are guiding circle. The first one is called that the angle at the center is twice angle at the circumference. So let's go the angle. They say the angle which an arc of a circle subtends at the center is twice that which is subtend that which it subtends at any point on the remaining part of the circumference. So this one is just grammar. We just call it that angle at the center is twice angle at the circumference. Okay, as simple as that. So now there are some cases to that. Okay, the first case is when you have a simple one that is like this. If this is the center and then we have two radius, okay, that make up a radii. Now this one is simply saying that two of this place is equal to this place. Very simple. Angle at the center is 2 times angle at the circumference, provided that they are facing the same side though. Please, that's how you know it. Like this one is facing up now and the other one is facing up. That is when it will work. For example, if they give you here now and they say you should find here, they are not facing the same side. So two of this place is not this one. Make sure they are facing the same side before you conclude that what the angle at the center is twice angle at the circumference. So let's have here to be P, here to be A, here to be B. We are going to prove it. So for B now, look at B. B said I have this one that is like this. And I have here A, B, P. Now look at this one now. This one is facing here, okay, and this one is facing here. That is how it's supposed to be. So 2 times this one is this one, and it's called angle at the center. If here is the center, please let here be the center O. Here is the center O. Okay, please don't mind the way my own circle is. Just assume that here is the center of this circle. Okay, so that is the B. Now for the C, I have another one like this, and that one is like this. This is the center of the circle, and I have a point that moves like this. Okay. So here is point P, here is center O. So the angle at point P here now, okay, and then and here, they must be facing the same way. This one is at the circumference facing like this, and this one is in the center facing like this. So angle at this center is twice angle at this circumference. So I have that here is what? A and what? B. So that is that. So we can prove it. We can prove it. So in proving it, we have to do a little construction. Just join line construction. Join line or extend line PO. Extend line PO or join PO and extend it to sorry, this is not like this. It's supposed to be like this. Yes, just like this. Here and here. Very simple. So let's do my construction now. Are you seeing it? Are you getting what I'm saying? This one is in the circumference, this one is in the center, and they are facing the same side. So 2 of this place is equal to this one, please. You need to notice. So these are the only 3 conditions you will see. Either this shape or this shape or this shape. These are the 3 shapes you need to see. So in proving it, you need to join line, join OP and produce it to Q. Okay, so which means we need to join this place and produce it to what? To Q. Okay, we need to join this place and produce it to what? To Q. We need to join this place and produce it to what? To Q. Okay, once we now join it, the next thing we do, let us name it. Let's decide to name it. Now if this one is drawn this way, let's say that here. Okay, now do you know that well, let's continue. Let us now prove. Let us prove. We want to prove that angle, the one in the circumference, angle APB, okay, sorry, the big one, the one in the center, angle AOB is equal to 2 of angle APB. Okay, that is angle at the center is 2 times angle at the circumference. That is what we want to prove. So that we have done our construction. Please, in proving your own, you need to write what you need to prove first before the construction. Please permit me. So pardon me, sorry. So the next one is now to prove. But let's continue. Or proof. Proof is that you want to start the job now. Now, since you want to start the job, do you know that line, what now? Do you know that line AO is equal to line OB? We call it radius. Yes. From here, from the center to any part of the circumference is equal to from the center to any part of the circumference. So we tell them that what? That line AO is equal to what? Line PO. Okay? They are the same thing. Line AO is same as line PO. Line AO is same as line PO. They are equal because they are called, my reason is what? They are radii. That's my reason. Okay? Now, if they are radii, which means here is equal to here, do you know that automatically that line, sorry, that angle APO is equal to angle PAO? Yes. Do you know that this angle here, this small angle, do you know that this small angle is equal to this small angle? Yes, because it is called base angle of an isosceles triangle. If you have an isosceles triangle like this, if here is equal to here, their base must be equal. If you have an isosceles triangle like this, if here is equal to here, their base must be equal. So my reason is what? Base angles of isosceles triangle. Okay, so let me call it X. Let me call it X. Okay, so therefore let me call this one x1 is equal to x2. So let me call it here that here is x1. Which one is x1? Okay, and here APO x1, and here is x2. Okay, now Do you know that that x1 plus x2 is equal to this angle now? Is equal to this angle AOQ. Yes, if you add these two angle is equal to this one. Whenever a triangle is being extended like this, okay, these two place is equal to this outside here, and it is called sum of two opposite interior angle is equal to one exterior. So we will say that what, that angle APO plus angle PAO is equal to what? Angle AOQ. Angle AOQ. Okay, my reason is what? Sum of two opposite interior angle equals one exterior. So you can write the sum of two opposite interior equals one exterior. Okay. So what does it mean now? That x1 plus x2 is equal to, if you add them, you are going to get 2x. Let me just say 2x1. Why? Because they are equal. So x1 is equal to x2. So they are equal. Or let me use 2x2 anyways. 2x2, anyone. Or 2x1, the one you like. They are the same thing. You still get the same answer. 2x1. Now, similarly, if we do the same thing in the left hand side, okay, similarly, if you do the same thing in angle, in triangle, if we do the same thing in angle BOQ, angle BOQ, if we do the same thing in angle BOQ, let me call this side, the same thing we repeated, let me call this one y1, y2, because they are the same thing. Here is the same thing as here. Radii, then the base angle must be equal. So this outside there would not be what? 2y1. Okay. So if it is 2y1, are you seeing something now? Can you now see that x1 plus x2, or rather, I want to show you something now. Let's decide to get, we want to prove that what? Angle AOB. Now to find angle AOB is simply to add these two things, which is what? Angle AOB is equal to what? Add it, 2x1 plus what? 2y1. Now if you factorize, they have 2 in common, so you have that x1 plus y1. Is it not true? And the x1 plus y1, look at it, x1 plus y1 is simply saying angle APB. So therefore angle AOB is equal to what? 2, this thing is same as saying angle what? APB. You see, very simple. Proved. Okay, you see, it's very simple. So we need to note, can I clean here? Yeah. So it's the same thing. So what you need to note is that one of the angle must be in the circumference, while the other one will be in the center, and they must be facing the same side. Please take note of that. They must be facing the same side. Let me check my time. Okay, we still have time. So let us just do proof in this particular video. So theorem number 2 said angle in the same segment of a circle are equal. Yes, that thing is called segment. Yeah, I just remembered now. Okay, that I was asking you that time is segment. So angles in the same segment of a circle are equal. Okay, now let us get that angle in the same segment. Let's get that. Okay, let us draw it. I have this. Now what do we mean by segment? If we just have any line like this, as simple as that. Okay, once they cross like this and you have two angles on the same segment like this, they are equal. That is what they are saying. In fact, these two are on the same segment. Here is equal to here. Yes, very, very important. So now here is P, Q, here is A and B. Okay, and here is the center of the sector O. Okay, now let us prove. First of all, we want to prove that angle APB is equal to angle AQB. That is what we want to prove. Now, the only construction you need to do, please, you must be writing this thing if you are asked to prove it. The only construction you need to do is to join AO and OB. So we need to join this place. Okay, now if we join this place, can you bear me witness that that angle? Okay, now let us prove now. Proof, which is the main thing. Can you bear me witness that angle AOB is equal to twice angle APB? Now, this place is 2 times this place. Is a must, because this one is on the circumference and this one is on the center, and they are facing the same side. So, and the reason is what? The first one we did, which is called what? Angle at the center is twice angle at the circumference. Circumference is written as OCCE. The C will be a subscript. Okay, so that is that. We agree with that. Okay, now do you agree again that angle AOB, the same angle AOB, is the same as saying 2 angle AQB? The same reason. Yes, angle at the center is twice angle at the circumference. This one is at the circumference, this one is at the center, and they are facing the same side. Now, anywhere I see this person, can I replace it with this? Yes. So I'm putting at 2APB is equal to what? 2, you must put angle, please, angle. 2 angle AQB. So if 2 cancel 2, therefore angle APB is equal to angle AQB. Proved. That is what we want to prove. As simple as that. Let's go to number 3. Number 3 said the angle in a semicircle is 90. The angle in a semicircle is 90. Okay, now that one is very simple, and I'm not doing any proof on that. Okay, that one is whenever you have a diameter, it must be a diameter. Do you remember what a diameter is? A diameter is simply any line that passes through the center of the circle. Okay, from one point of the circumference to the other side is a diameter. Now, anywhere these two diameters meet on the circumference must be 90 degrees. Very simple. If they met here, here must be equal to 90. And even if this one is coming up to like this and this one met it here, as far as the line there is what? Is a diameter, is equal to 90. Anywhere they like, let them meet. Anywhere they meet on the circumference is 90 degrees. That is simple what this one is saying. If you want to prove it, the same first one will give us the proof. We are not constructing anything. You know that from here to here, this is what? 180 degrees. Angle on a straight line is 180 degrees. And don't forget that angle at the center is twice angle at the circumference. So if here is 180, then half of it will give you this one, 90. That is just how to prove this one. It's not difficult to prove. Okay, so you can try it and show me on the comment section. Okay, very simple. We've known number 3, and number 3 is simply called angle on a semicircle. First of all, it must be a diameter, and anywhere the both of them met on the circumference must be 90 degrees. Number 4 said angles in opposite segments are supplementary. Okay. And in another words, we call it opposite angles of a cyclic chord. Okay. In other words, you can call it the sum of opposite angles of a cyclic. It must be a cyclic quadrilateral of a cyclic. Is this CYS? Cyclic chord. But it must be a cyclic quadrilateral is supplementary. I hope you know what supplementary is. Supplementary means they are equal to 180. Okay. Now, we look at what that one is saying. Very simple. If I have a circle like this, okay, a cyclic quadrilateral is simply that this is a circle. You now have a quadrilateral inside of that circle. A quadrilateral is an angle that has is a shape that has 4 angles on it. So now those 4 angles must be touching the circumference, please, before you conclude that is what? A cyclic chord. Sometimes they will do this thing for you, and then you go and call it a cyclic chord. Now, if you look at this, is the first angle, second angle, third angle, fourth angle. Now, this is a quadrilateral, but it's not a cyclic chord. Why? Because the edges are not, all the edges are not touching the circumference. The 4 edges must be touching the circumference before you conclude that it's a cyclic chord. Please note that. So now, what do we mean? If you add this place and this place is equal to 180, add this place and this place is equal to 180. As simple as that. Okay. Very, very simple. If you have that here is x and here is y, maybe here is a m, here is n. We are simply saying that what? X plus y is equal to 180. And my reason is what? The sum of angles in a cyclic chord. Very simple. Or you say that m plus n must be equal to 180. The same reason. Okay? So the next one, theorem 5. Theorem 5 said the exterior angle of a cyclic chord is equal to the interior opposite angle. Okay, now look at what that one is saying. That, and if I have a circle like this now and I have a cyclic chord, don't forget what I told you about cyclic chord, that the 4 edges must be touching the circumference. Here must be touching the circumference. Now look at what that one is saying. This one is saying that if it's a cyclic chord and I have a line that is extended like this, that here now is not equal to this place but equal to here that is directly opposite to this one. So if here is x, automatically here is x. Now if I extend this one like this and here is m, here is not equal to this one close to it, is equal to the opposite one. So if here is m, here is m. Okay, so if I extend this one like this and maybe here is n, if here is n, automatically the one opposite it is what? N. Which other one? If I extend this one like this and here is y, for example, if here is y, automatically this place is what? Is y. So it is called what? Opposite interior angle of a cyclic chord is equal to the exterior angle. Okay, or you start from the exterior angle is equal to the opposite interior angle. Very, very simple. Okay, can I clean? Yeah. So number 6. Now let's move into tangent. Tangent to a circle. First of all, if you have a circle like this, any line that touches through the circumference like this is called the tangent. Okay, so this is the tangent. If I have another circle like this and this one passes through like this, as far as it touches the circumference, it is called the tangent. Anyhow it is, as far as it touches the circumference, it is called the tangent to that circle. Okay, now the first theorem here, number 6 now, said that what? A tangent is perpendicular to the radius at the point of contact. Now, if I have the center of the circle like this, okay, and the line is drawn from the center to any part of the circumference, don't forget that it's called a radius. That a radius makes an angle 90 with the tangent. Very simple. Okay, a radius makes angle 90 with tangent. So don't forget that the line, that the radius of a circle makes angle 90 with the tangent at the point of contact. So we say that what? If here is O, A and B, we say that angle OAB is equal to 90 degrees. The reason is what? Radius is perpendicular to tangent. That is how we write it. The radius is perpendicular to what? To tangent. So the next one we need to know, number 7, we are still on tangent. Number 7, if I still have a circle like this and I have a tangent anywhere, let me just use this side. I have a tangent like this. Now, if you have a triangle inside it, it must be a triangle. You have a triangle inside it like this, okay? Then this thing is simply saying that what? That here, this side, okay, that if here is x, that this side must be x. As simple as that. Did I get it very well? Let me draw it like this. So if you have a distance like this, it must be a triangle, and that triangle must start from here. A triangle. So here now is equal to which side? Sorry, I didn't draw it very well. Let me draw it again. I have this, and I have a tangent, okay, and I have a line like this, okay, and then I now have 2 points like this. That here now is equal to here. Yes, this is correct. Okay, or maybe you have it like this, and then you have this one like this. Once you have a line like this and it forms a triangle, anywhere it forms a triangle, that here is equal to outside here, and it is called that what? The angle between a tangent to a circle and a chord drawn, and a chord through the point of contact is equal to the angle in what? Alternate segment. So we just call it that, or we just say that in short form we call it alternate segment. So if here is x, we say that here is equal to here, and the reason is called alternate segment. So if here is A, for example, A, B, C, D, okay, we say that angle ABC is equal to angle BDC. My reason is what? Alternate segment. Alternate segment. Okay, so that is that. So this is number 7. Number 8, still on tangent. Don't worry, you will remember all these things. When we start solving questions, you will remember them. Okay, or just try to memorize them before we start solving questions. Number 8. Number 8 said that if I have a circle like this, this one is not even a tangent, and we have 2 chords. Look at 2 chords like this. If you have 2 chords like this, that anywhere they met, whether they met inside, whether they decide to meet inside or outside the triangle. Like let's say that this one met outside the triangle. Okay, let's have another one that will meet inside the triangle. As well as is a chord. I have a chord like this, and maybe another one like this. Whenever you have 2 chords, okay, this one said, let me read it out. It said that 2 chords PT and QR of a circle intersect outside or inside a circle at point P. Okay, now whenever they intersect, let me have that here is PTS, RS, PTSR. Now in this one, we don't normally use this one to find angles. We use this one in finding the length. You will use it in finding the length. This one is simply saying that what? That line PQ times line QT, okay, is equal line PQ. Line PQ, oh, here is Q, sorry. Here is Q. Okay, line PQ times line TQ is equal to line QR times line TR. Okay, don't mind that my own is not straight, it's supposed to be straight. Is equal to line RQ, sorry, times line SQ. Okay, we use that in finding the, if here is Q, their point of intersection is Q. So the major chord first, that is PT, line PT times then the smaller one times PQ, okay, is equal to the bigger one SR times what? SQ. Okay, so that is that. That is that. Okay. Number 9. Number 9 said two tangents SR and SK to a circle with center O are equal in length. In this one said, if I have a circle like this one is tangent, and I have two tangents that met at a point outside the circle, okay, they met at point S, and then we have that this is the center of the circle. From here to here is the radius, from here to here is the radius. That the line that is drawn from this center to what? To that point where they met, bisect it. So here must be equal to here, that it bisect it. So, and then this line must be equal. Okay, as simple as that. So you need to note that. You need to note that, very important. All right. So number 10. Number 10 said, if I have a triangle like this and I have two chords that met outside. Two chords that met outside, okay? Oh, sorry, a chord and a tangent. Sorry, this one is a chord and a tangent. You know, we have done the major ones. All these ones, you hardly see them in exam anyways. You hardly see them in exam. And they are just for they are not for finding angles. They are for finding the length. The length. If you have this one said that this one QS, which is the tangent, that QS, line QS all squared, is simply this one QR times RQ. KR times what? RQ. So that is what this one is saying. Okay, KQ and RQ, sorry, KQ times RQ. KQ, not KR. KQ times RQ. Okay, so then the last but not the least, number 11. The last but not the least, number 11. Then in our next video we start solving problems. So I have two circles like this, okay, from the center to the radius to the circumference, from the center to the circumference, and I have that this one moved, this tangent moved this way to meet this one, okay, and then I have that this one moved this way to meet this one. Don't forget that this one met at 90, this one met at 90, okay, and their point of intersection K. Then I'm having that here is R and here is R, the radius. Okay, so this one is saying that that R over R is equal to OQ over QW, is equal to OQ. This is O and here is W. So is equal to what? OQ over what? OW. Okay, so that is that. And is still equal to what? SK over what? TK. sk. Where is my s? Here is my s, and here is my t. Okay, so this one is simply saying that this over that sk, this one over this one over kt is equal to the other one, okay, okay, over what? Over what? kw, kw, and they equally say that is equal to the radius. So that is that. So in our next video we solve problems on that. So thank you very much for watching. Please subscribe and share to anyone that needs it.